Okay, so now that we know that lateral area is perimeter of the base times the height, let's go find the lateral area on these two prisms here, and we're going to round our answer to the nearest tenth. So first thing you have to do is determine which are the bases, which sides of this shape are the bases, are the non-parallelograms. And so those would be these two trapezoids on the front and the back. Okay, and so we're going to say lateral area equals perimeter of the base. And you don't have to write this out if you just want to say P times H, but I find early on that people forget what does P mean again, what does H mean again, so I just think it's helpful to write it out. Okay, so our base here, they're congruent polygons, so I only have to do one. But the base of this trapezoid here, we're going to find the perimeter of that. So that would be 9 plus 20 plus this 10 is referring to this length right here. I know that's not abundantly clear. Plus the top, which is 10. And then the height, remember, height is the distance between the bases. So how far is the distance from one trapezoid to the other? It would be 12. Okay, and then we're just going to put that in our calculator. So we have 49 is what 9 plus 20 plus 10 plus 10 is, times the 12, comes out to be 588. And that would indeed be centimeters squared, because it's still area. It's just area of all the sides. Okay, so tell you what, let's make, well, no, I'm going to go through this one with you. So lateral area is perimeter of the base times the height. Okay, so the perimeter of the base, these are, again, our non-parallelograms, are shapes that are our bases. Here are the front and the back hexagons. Those are regular polygons, we know, because it's got the tick marks all the way around. So our perimeter of the base is just going to be 4 times 6 sides. And then what is our distance between our bases? That's our height. BT dubs means between, not by the way. Distance between the bases. We said was 16. Okay, so we're going to put that in our calculator. So 4 times 6 gives us 24. 24 times 16 gives us 384 meters squared. All right, so now we're ready for the total surface area we alluded to before. That is lateral area. It's the area of all the sides plus the area of the two bases. So the way that we write this now, we know that this is P times H, perimeter of the base times the height, plus, then we're just going to leave this as 2B because our B will be a different shape depending on the kind of prism we have. So keep in mind this is area of the base, and it's going to change every time depending on what kind of shape we have. So here we go in example 2. Find the surface area of each prism. Okay, so our surface area, total surface area, is perimeter of the base. I'm going to write this where I have more room. Perimeter of the base times the height, and all that part, all of this we call lateral area, because that's the area of the sides. It feels weird that you're finding the perimeter of the base in order to find the area of the sides, but that really is how it works, plus 2 times the area of the base. And again, I'm writing this out. You don't have to write out this whole formula if you just want to write plus 2 bases. But early on, when you're still getting used to these formulas and what they mean, I find it helpful. Okay, so here we go. So perimeter of the base, again, my bases, my non-rectangles, my non-parallelograms are the front and the back hexagons. I like to label those with a big B just to keep it straight, which ones are the bases, right? And then from there, the perimeter of the base, these are regular hexagons, so all the sides are congruent. So we're going to say we've got 6 for each side times 6 sides. That's going to be my perimeter of the base. Okay, then my next step, remember height is the distance between the bases. By the way, we are only in this class going to find the surface area of right polyhedrons. We're not going, and prisms, we're not going to do surface area of oblique. We just don't have time. So our height for the purpose of surface area will always be that lateral edge, that distance between the bases, which in this case would be the 12. Okay, and then plus 2 times area of the base. Now, here's something interesting, is we have to think about what kind of base we have. In this case, it's a regular polygon. And then we have to think about what formula we use for a regular polygon. So that's 1/2 apothem times perimeter. So I'm just going to plug in that formula for now. 1/2 apothem times perimeter. All right, so now, let's see, I'm going to go ahead and multiply this out. The 6 times the 6 times the 12 is 432. Plus, some other magic I can work here, some math magic, is that this 2 and this 1/2 are going to cancel out. So I really just have apothem times perimeter. Now remember with me, we already found the perimeter, right? We already said that the base has each side of 6, and then there's 6 sides. So I'm going to go ahead and throw in here that the perimeter, this is my P, is 6 times 6. Okay, and then all we have to do is find the apothem. Remember our strategy for this. We're going to divide this hexagon up into 6 equal triangles. We're going to take 360 degrees and divide it by 6 to find those central angles to each be 60 degrees. And remember, the whole point of this is because that's going to give us some angle measures that are going to allow us to find the length of our apothem here. So our A, so that 60 further divides into 30 and 30. And you know what, I'm just going to draw this triangle. I'm going to zoom in on that and draw it over here so that we can see what we have to work with. We've got a 30 degrees at the top, 60 here at the bottom. And we know if it's 6 all the way across the side, it would be 3 just for the bottom of that green triangle. Okay, so if 3 is across from 30, then across from 60 would be 3 square root 3 for that apothem, that A. So now we can plug that in. So we have 432 plus our apothem is now 3 square root 3 times our perimeter, 6 times 6. I believe it told us to round our answer to the nearest tenth. So we're going to put all this in the calculator. 432 plus 3 square root 3 times 6, and I'm getting a final answer of 619.1 inches squared to the nearest tenth. Okay, so I'll see you in the next video for we're working a couple more of these.